All right, this one is probably as ugly as you're going to see in this section here. It's 3 to the 2x minus 1 equals 5 to the x plus 2. We start getting these binomial powers, or you can even have trinomial powers, whatever powers they throw at you. Okay. The main idea here again is where is x located, and the answer is in the power level. We don't want it up there. So again, I can't make 3 become 5 or vice versa. Just 3 to the second power is 9. It skips over 5. I can't even 5 to any power. I got to go backwards to get to 3. So there's no way to make them the same power like we did in example 1. So I need to log both sides. Again, I don't see e or 10 showing up, so I'm going to go ln, because that's my favorite one. ln 3. I'm going to recommend that you put 2x minus 1 in parentheses right off the bat, because that's where it belongs, is in parentheses. And if you put it right there, you might not forget to do it. And I'm going to log this side also, ln of 5 parentheses x plus 2, like so. Again, those things are still up in the power level of each of those logarithm statements. But the powers are 2x minus 1 and x plus 2. When you pull them out in front, so when I take this 2x minus 1 out in front, the entire power 2x minus 1 is being multiplied by log of 3. And the entire power x plus 2 is being multiplied by log of 5. Alright. And if you don't put those parentheses, you might not remember, hey, I got to do a distributive property here. So the 2x minus 1 is the power, so when you pull that power out in front, the entire power is there. So when I simplify this, distributive property here, distributive property here. Again, if I'm going for an exact answer, I'm just going to keep it ln 3, ln 5 in my work. If I'm going for an approximate answer, I would immediately type in ln 3, ln 5 equals, get some decimals over here. I'll do it both ways again just to show you the difference in work. I'm going to shrink this up just a smidge so I can fit more stuff over here. Alright. So the difference in the work here is, at this point, if I'm going to get an approximate answer, 2x minus 1, and I type in ln 3, my calculus says it's 1.0986. And then I've got x plus 2. And if I do ln 5, it is 1.6094. So once you get an approximation in there, again, 4 decimal places, now you're not dealing with logarithms anymore, you're just dealing with numbers. All right, so at this point, it's just a numerical equation. You solve like a regular numerical equation. We'll put this in the back burner. Go ahead and finish off our log one. All right, I much prefer this personally. I don't need a calculator to do this. Over here, I need a calculator. So anytime I can do something without a calculator, I find that to be better. Just me. So in this case, 2x ln 3 minus ln 3 equals x ln 5 plus 2 ln 5. Just basic distributive property going on there, nothing weird. Ln 3 times 2x makes that. Ln 3 times negative 1 makes minus ln 3. X ln 5 and 2 ln 5. Once you do a distributive property, now you're left with just a basic algebraic equation. And when I say basic, I mean in the fact that some terms have letters, some don't. All right? And back in algebra, when we had some terms have letters, some terms don't, we got rid of all the parentheses. Our next step was to rearrange things so all the letter stuff was on one side, all the number stuff on the other side, right? So I'm going to move the x ln 5 to the left. I'm going to move the ln 3 over to the right, leaving everything else where it's at. So I'm going to get 2x ln 3 minus x ln 5 is equal to 2 ln 5 plus ln 3. Basic algebraic technique there. If you move something, it changes signs. If you don't move it, it stays the same sign. So 2x ln 3 stayed positive because it stayed on the left. X ln 5 became negative when it moved across the equal sign. The 2 ln 5 stayed positive because it stayed on the right. The ln 3 moved over to the right, became positive. Right? Now, what's going to happen when you're doing this, and again, for the exact answer, is you're going to probably get multiple terms containing x, multiple terms not containing x. Okay? The side containing x, I'm going to take out a common factor of x. That leaves me, if I take x out, with 2 ln 3 minus ln 5. Over here, I've still got 2 ln 5 plus ln 3. Okay, and this is where it gets just a little bit weird. And not even weird, but just you want to do this. All right. I've got a bunch of log stuff here, a bunch of log stuff here. I just want to get log. I don't want to have stuff added and subtracted and multiplied and all this other stuff. So I'm going to use my laws of logarithms to unify these expressions. Now, this 2 can go up here, right? Yeah. And this 2 can go up here the same way. And if I'm doing log minus log, it's going to be first argument divided by second argument. 3 squared is 9. Second argument is 5 divided by 5. So this whole thing in this parentheses can be transformed into just log of one thing, which specifically is 9/5. Same deal over here. I've got log of 5 squared plus log of 3. The rule says if I'm adding logarithms, I multiply the arguments. This argument is 25 times that argument 3 makes a natural log of 75. Times 3 multiplying because it's plus, 9 divided by 5 dividing because it's minus. And then that tells me that x equals the log of 75 over the log of 9/5. And then we write down our classic solution in logarithmic form, log of the top base the bottom. That is the exact answer in the way I would expect to be written. There we go. So again, if it's asking for an exact answer, that's what I'm looking for an exact answer. Log of some number, base some number. All right. If it's looking for an approximate answer, which is the default in my opinion. Okay. If it doesn't specify find me the exact answer, I'm going to use the default here. Just know how to do it. What I typically do, I can't remember the homework specifically if they say to find exact answers or not. The place this is going to come back is on the quiz or test. I think it's going to be a test on this one. On the test, there's going to be a bonus on the test that if you give me an exact answer for the problem, I'll give you bonus points. So, do you want to practice a little bit? Probably. Will it show up in the homework specifically? I don't remember. I always show people how to do it, but then I think that the homework defaults to the approximate answer more often than not. But just know that I didn't use a calculator that entire time, right? I used a calculator here to get to here, and now I got to start doing distributive property. And maybe it's easy to multiply these things, maybe it isn't. But 2 times 1.0986, I can do it in my head, but I'd rather do it on the calculator. 1.0986 times 2 comes out to 2.1972 minus 1.0986. Okay, x on that one, and then 1.6094 times x. And then plus, and then 1.6094 times 2 comes out to 3.2188. Again, moving things around, I'm going to move 1.6094x over here, move 1.0986 over here, subtract 5878. And add these up, you get 4 carry 1, 7 4.3174. So to get the answer, I got to divide by 0.5878. 4.3174 divided by 0.5878. Oh, thank you. $7.35. That's the approximate right answer. Again, if we want to verify solution, one thing I can do, if I already did the exact answer, if I do ln 75 in parentheses divided by ln of 9/5, it should equal pretty close to 7.35, which it does.
I was going to say that is if it asks for the approximate, you want us to do it that.
I mean, I would do it this way. You could also get the exact answer, then just type that in, hit equals.
Yeah.
You know, I mean, that works. Well, I mean, if you're going to go to all the trouble of finding the exact answer anyway, you might as well do it this way, and then just when you get to that step, just approximate it at that point.
Okay.
But if all you're looking for is the approximate answer, then I would go immediately get the logs out of the problem and work it out. All right. If I were to try that out, 3 caret parentheses 2 times 7.35 minus 1. And if I do 5 caret parentheses 7.35 plus 2, should equal close to the same number, off by about 9,500. Okay.
Yeah.
But compare the size of the error to the size of the numbers.
Yeah.
9,500 compared to 344,000 is not that big a deal. Plus, it was a pretty drastic rounding. We went 3, 4, 5, so we went a half. You know, so if we'd gone with a more accurate, let's go 7.3453 even. 3 caret parentheses 2 times 7.3453 minus 1 and 5 caret parentheses 7.3453 plus 2. Much closer, by less than 100. All right, so again, look at the size of the rounding. You know, if you're at a 0.5 or at a 5 level and go up, or 4 and go down, you're kind of in the middle. It's going to cause for a little bit more error, so don't concern yourself with that. I mean, being off by almost 10,000 when the number is 344,000, that's
Not
still, I mean, that's less than a 1% error, so it's still pretty accurate.